Am I audible? Hello. Good evening, Prabhu.
Yes. Yeah. Hi. Good evening. Can you hear me?
Hello. Actually, your voice is little bit distorted. I think. So we will wait for few minutes and we will wait. Let's see who join, and then I will proceed with the discussion part. So good evening, everyone present here who has joined this online session. So my name is Manitnam Prakash, and I am from IIT Kanpur. So I am here for problem solving session. So the core name of the course is Industrial Wastewater Treatment, that is NPTL course. So those who have planned to attend this course, so a online problem solving session will be conducted. I think there are total two TA. There is one more from IIT Bombay, and my I am from IIT Kanpur. I think IIT Bombay person meets you on Sunday. I'm not sure, and my session is on Tuesday. So you can join any of those session. So the name of the course is Industrial Wastewater Treatment, and the course instructor is from IIT Dhanbad, that is IIT ISM Dhanbad, Professor Alok Sinha and Professor S.K. Gupta. So, so this is my schedule that every Tuesday I will be meeting from 6 p.m. to 8 p.m. via Google Meet, and the link for which has been already shared with you. But it will be a weekly notification will be again sent to you just for a reminder. And the recording of this session will be uploaded on YouTube channel, and the link for YouTube channel will be also shared with you in upcoming weeks. So during discussion part, if you think some important, if you have missed some important parts, then you can just come back and just rewatch it on YouTube. Okay. So first I think many of those who have those who are attending the first, like for first time, this problem solving session. So I will explain you how things will work in this lecture and in upcoming lecture also. So as this is known as problem solving session, so and it is for 2 hours. So for initial maybe 45 minutes or maybe for 1 hour, I will be re, uh, re I will be like going through the whatever the material that has been circulated to you. Yeah, the lecture notes that has been given to you. So I will be just recapping in a very very brief manner, not in a detailed way. I will be just going through some of the part, like this has been taught and this has been taught. So one of the most important, you will be benefited from this course one, this problem solving session only if you have attended your, if you have watched your video. Because and so I will be just recapping those things which have been discussed in the video. And then at the end of the session, that is another half, I will be discussing some questions that might be given to you for assignment purpose, or at the end of the examination, if you are planning to attend your final examination. Okay. So 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 this will be overall view. First there will be some discussion, and then there will be some problem solving session where there will be a 10, I have been given 10 sets of questions. I have prepared the solution, and those solution will be discussed in very detailed manner. If you have if you have any question or any doubt, you can just unmute yourself and you can ask, or you can just write in chat box. I will be happy to help you. And there might be chances that I might not be able to answer your question also, so I will note it down. I will try to answer it in next session. So if I am not able to answer, just don't think that, like, I am also a student. I am also PhD second year student, so there are chances that I might not be knowing everything. Okay. So let's start this week one lecture. So in week lecture, so as it is known as industrial wastewater. So in wastewater, first there was a brief introduction about wastewater. What is wastewater? What are different kind of wastewater? Then there was more emphasis on this industrial wastewater. What are its different source? Then some of the characteristics of the wastewater. Then how wastewater is managed. Then then we came into the treatment part, how this wastewater is treated. And some part there are several units to treat industrial wastewater. So one of the part was discussed in the first lecture, that is equalization tank. Okay. So again, as I said, that I will be going through some recapping process. So I will be just going through this definition of wastewater. So I think this is everyone are familiar with this thing, that what is this wastewater. So wastewater can different organization, different rule making organization have defined it in a different way, but overall this wastewater can be summarized in this thing, that any water adversely affected by human related influence may be considered as wastewater. Human related influence means, like, might be due to some domesticated work, or it might be due to some commercial work, or it might be due to some industrial work. Then if something has happened to our normal water, then we call it as just a wastewater. Includes substance from domestic, industrial, commercial, and agricultural activity. So these are the different human related activity that affect our wastewater, and that convert our normal water into wastewater. Okay. And final outcome is, once the water is affected by human activity, then that water is become unsuitable for immediate use, and that need treatment. So if you some there is some intervention from human side, then that water must be treated, and after treatment only, then we can either reuse, or we can just do another kind, some other kind of work. There are several type of wastewater. Like, first is the most common wastewater, that is domestic wastewater. So for domestic wastewater also, there is one course online going on. I don't know, remember this time or in next semester, there will be some one course. There is one professor, Manoj Kumar Tiwari, who is the course instructor of domestic wastewater. So that's for your knowledge. So domestic water is that we see in our household, originates from household and residential area, include water from sink, shower, bath, toilets, washing machine, dishwasher, categorized into grey water and black water. What is this grey water and black water? I will be discussing in Next slide. So domestic water is the wastewater we see on regular basis in our home, in our street and all. So coming to this black water, this domestic wastewater can be like, there are two type of domestic water. One is coming from our toilet waste, that is mainly organic in nature, okay, contain nitrogen, phosphorus, microorganism. Okay, now when we I'm talking about toilet waste, it is considered to be both human feces, urine and all these things. That it means, it can be also said as bathroom waste. Okay, then something called gray water, that is coming from kitchen waste, bathing, where there is less amount of organ you can see that it contains like detergent, surfactants, salt and all these things. Okay, and the overall domestic water will be combination of black water and gray water. So in this lecture we are not focusing on this wastewater, this domestic wastewater. We will be more focusing on industrial wastewater, but one should know what are different kind of wastewater. Okay, then coming to the industrial wastewater, which uh, which we'll be discussing in very depth, generated for industrial and manufacturing process. So like what happened that suppose I am in Kanpur. So Kanpur is a major industry, has a major industry of leathers. So if, you might have heard also that Kanpur is known as leather city of leathers. So what happened that for manufacturing of leather, they use something called chromium, basic chromium sulfate. So once they are like they are making something from leather, they have to treat their, because we know that our leather, which is initially human, which is coming from, sorry, animals, is very soft. So they, to make them very stiff and to convert them into some, to give them some shape, they use chromium sulfate. Okay, so what happened that, and after treatment what will happen that this chromium will be leached out in normal wastewater if not treated well. Like there is province in every industry that if you are using this salt, then you have to treat. But we know that some industry are not following those norms. And what happened that if water is discharged in normal sewage or in normal channel, then it will like it will be mixing with our normal water. And somehow this, you can say that that industry is producing some kind of a wastewater, that is industrial wastewater contaminated with chromium. Okay, so this was just example of chromium. I think overall there are many examples from many places, like cadmium problem, lead problem, lithium problem. So if you are residing in some industrial area, then you might have heard like this kind of problems are there. As I am in Kanpur, so I am giving in chromium problem. In Kanpur there is a huge problem of chromium. And whatever treatment plant is there, see what happens that as per norms there should be separate industrial waste supply line, industrial waste, domestic waste. But we are not so advanced. So what happened that this industrial waste and domestic waste all are combined together and they go into wastewater treatment. So somehow this makes our treatment plant very, it's like inefficient to treat our wastewater. Okay, so generated, this was just overview. You can say a little bit detour from our discussion. So generated from industrial and manufacturing process, contains pollutant like chemicals, heavy metals and organic matter. Like chemicals, heavy metals like chromium, arsenic. Arsenic is generally geogenic, but you can say lead, cadmium and all these things require a special treatment. So treating, now consider one wastewater is simply containing nitrogen, phosphorus, that can be treated easily. We have many technology, many advancement. But if your water contains some kind of these material like heavy metals, then you have to treat in a very specific way. A high investment is required, high money is required. That's why we need to study like how this industrial wastewater can be treated in a efficient way. Then something called agricultural waste. We know that what is agriculture, coming from agriculture. See, if we are talking about agriculture, it doesn't mean just only land. It also contains the wastewater which is coming from the poultry livestock operation like poultry farm, yeah, fish farming and all these things. This thing also comes in agricultural thing, okay na. Contain pesticide, fertilizer, organic matter from annual waste. Then a storm rainwater, we are also familiar. This runoff from the precipitation events like rain or snow carry pollutant from urban area. Okay, so like whenever there will be rain, what will happen that a huge amount of water will flow. It will whatever the sediments, yeah, still like soil is laying on the ground, that water will erode that soil, and the water will be, which will be generated will be a storm water waste, a storm water, yeah, storm wastewater, you can say anything, okay. So these are the basic component of the wastewater. Like primary majority of the portion is our water only. Organic, there is organic matter is also presence of presence of organic matter. High organic matter is there, then we can say that it is a domestic wastewater. Include food waste, human waste, biodegradable material. Then nutrients also, we know that from kitchen waste or from kitchen waste uh, we will be like from kitchen waste, if that kitchen waste is in supplied through the waste, just sorry, um, then nutrients such as nitrogen, phosphorus, what can cause, so this is talking about nitrogen and phosphorus that is coming from the agricultural waste, okay na, because we know that in our pesticide and all these things we have huge amount of nitrogen and phosphorus. These are beneficial for plants, but if more fertilizer are added, then it can, sorry, I'm speaking something. So see, nutrients means like it is consisting of everything from agricultural waste, from domestic waste and all these things, okay na. Then something called pathogens, like pathogens are there. We know that if wastewater is there and it contains some kind of organic matter, then it became food for pathogens, and it will start growing, and eventually it will be start decaying, and you will be getting foul smell and all these things. Then chemical pollutants like from industrial and agricultural, and then heavy metal again from industrial such as lead, mercury, cadmium, chromium, everything, okay. So there are several practices of wastewater management, that there should be proper collection of wastewater, like there should be proper channel, then it should be disposed, and if water is not so much contaminated, then it should be reused. We have learned about this thing, okay na. Treatment process required physical, chemical, biological method to remove contaminants and ensure water is safe for discharge or reuse. Remember, we have to we are seeing that once the wastewater is generated, we have to treat it, and once the wastewater is treated, then we have two purpose. I what I mean to say that there is one in India, there is one pollution control board known as CPCB, Center for Pollution Control, Center for Pollution Control Board, okay na. So this has set some norms, like now if you are treating water, you either you can reuse it. Reuse it means depending upon the how much you have invested in your treatment, then depending upon that how much advanced treatment process have you applied, if the water is suitable for reuse. Suppose water means like there is particular requirement that if it should meet certain criteria, then that water is suitable for drinking purpose. If the water, if the treatment process has been such that it is meeting the all the standard criteria for drinking water, that is 1050. We know that for drinking purpose we have is code 1050, okay na. So it has defined some limits that pH should be this much, chloride should be this much, calcium should be this much. So suppose there is one wastewater is generated, and that is being treated, and after treated it is meeting all the criteria of is 1050, then it is suitable for drinking. Similarly, there is some provisions for, suppose if you want to, after treatment, if you want to reuse for agriculture purpose, then it should match certain criteria. Because we know that for, if we are supplying any water for agriculture, then it should not have high phosphorus, high nitrogen. Then again, that water will be reused. Now there is something called discharge. So suppose your treatment plant is not that much efficient, so what happened that you have only option to discharge. Now discharge can be done at three places. One in discharge can be done at one open land, then discharge can be done in lake, or discharge can be done in river, or discharge can be done in ocean. So this CPCB has set some limit. Like if you miss for every, like there is something called dissolved oxygen. There are many factors, but suppose I am giving one example of dissolved oxygen. For our, in when wastewater is treated, when wastewater is produced, the dissolved oxygen is very low. So now you have to treat your wastewater in a such a way that you have to treat, suppose degree of treatment is such a way that DO has reached some level, say suppose X, and it qualify for this thing that it can be discharged in land. Then if that norms is passed, then this water can be discharged in at land, inland. Similarly, there is some certain criteria for uh, lake, certain criteria for river, and certain criteria for ocean. So I will I miss, if you are interested, just go and check the what are the different standards set by CPCB, that is Center Pollution Control Board, that if what should be the degree of treatment, so that I can discharge my water in these five, in these four places, or what are the different criteria, so that I can reuse my treated wastewater. Okay. Then importance, why we know that we have to protect our we have to protect ourselves. If we are generating waste, then it will somehow, it will be, if suppose if without any treatment, now suppose suppose without treatment, if you are discharging any wastewater, then what will happen? It will be mixing in our, it will be mixing in river, it will be mixing in lake, and then that lake or that river will be also polluted with wastewater, and it will be just causing a human health effect only. And not only human health, it will be just affecting aquatic life and all these things. So we have to maintain, like we have to protect public, we have to protect environment, and conserve water resource. We know that our fresh water is very limited. We have been reading from our childhood only that something out of we have very limited amount of water, and if we are doing this wastewater thing, then it will just cause, it will be a burden for our current water resource. Okay. So discard, I think so this was all about this actually whatever I was showing you, I was showing you from this mm, from your from the material which you have been given. So I think all of you have gone through this material. Anyone have you received this PDF file, like lecture 1? Yes. Yes. So I was just like actually in this PDF there are many things. So whatever was possible for me to write in PPT, and that PPT will be also available to you, and this PDF is already been given to you. Okay na. Till now, if you have any question, you can ask. Chat box is always open. You can write anything in call message. Yes, sir. In chat box, you can write anything if you have any question, and if you think I am speaking something in a not a correct way, or if I have given you some wrong information, you can just objectify. But I try my best not to give any wrong information. But as already said, that I am also a student. How we treat fluoride in wastewater. So see, for treatment of fluoride, there are many things. Currently, people are using adsorption process, like use of activated carbon. uh, then there is something called use of activated alumina, but activated alumina is not used because activated alumina itself leaches aluminium. Okay, so an aluminium is not good for health. And there is one Nalgonda technique is also there. Now in Nalgonda technique we know that we add alum and this Nalgonda technique is very famous, like we add alum and what we add lime. But problem with that is that alum contain aluminum and sulfate, so both are so these are some of the common process. I'm not going to say how we can treat. And there is these were adsorption process, and there is something called coagulation precipitation process also. Like some people are using, if we have fluoride contaminated water, then we are adding calcium and phosphate, and calcium and phosphate react with fluoride and they precipitate fluorapatite. Okay now, so in that way also this uh, fluoride is treated in wastewater. But if you want to see on larger scale how this fluoride is being treated in wastewater, then the use of activated alumina, use of Nalgonda techniques, and then use of activated carbon also are being currently used. There are several examples in Rajasthan. There are several examples in Rajasthan where in treatment plant they are using this kind of technology to treat fluoride. So I hope I am able to, like, I am not able to answer. Means I am not saying the correct process, but I am just showing the idea that how these things are working. Fluoride treatment are going on. But remember, there is problem with activated alumina and Nalgonda techniques. The problem of aluminium. So if you are working, I don't know, are you a student or are you working in some? Are you a student or are you working at some place? Mihir, I'm working. Okay. So I will suggest you go on Google Scholar. You just search fluoride treatment in wastewater. You will get many method. One method. This was there is something called adsorption. I hope you are familiar with adsorption process. And there is something called precipitation process. So adsorption process is, I have told you, precipitation is also with the help of calcium. This treatment process also depend upon how much fluoride is there. Okay na, so if high fluoride is there, then what happen that people add calcium in water. So what happen that calcium and fluoride react and they precipitate CaF2, and this CF we get treated wastewater, fluoride free water. Okay, so this thing I have already covered. Any more question, anyone? Any more question? Okay, so this thing I have already covered, like what is wastewater. You can see this thing, this figure. Then wastewater, surface under industrial, domestic, and then in domestic we have grey water, black water. This thing I have already covered. So our main aim will be this thing, industrial wastewater. So we have seen that textile industry. In textile industry for coloring purpose and all this thing, we use a huge amount of some material. I'm not sure, but cadmium is generally used. Just go and check in what kind of chemical are used in textile industry. There are metal industries, several metal industry, aluminium, iron. There are huge amount of, similarly paint. In paint we use lead. Okay now, so wherever there is a paint industry problem, wherever there is a paint industry in nearby, several people has reported that there will be some lead problem. Then with dairy problem. In dairy problem, what happened that a huge amount of organic, we know that milk and all this thing, and milk is produced, but along milk are produced with the help of some kind of is milk um, then pulp and paper industry, leather industry. I was saying that wherever there is a leather industry, you will see chromium problem. and chromium problem is very severe. Just I for your, if you are curious, just search leather, just on Google Scholar, just search this thing, uh, uh, chromium in Kanpur. Okay, now you will start. The first thing will be like this thing that Kanpur, the city of leather, uses chromium sulfate and all this thing. Okay, so these are some of the industrial wastewater, and there is nuclear wastewater, uranium problem, and all these thing. Okay, storm water we have already talked. Common pollutant food. This thing we have also seen. Miss, I have discussed in very short, like suspended solid and all this thing. Then we have see this thing I have not discussed. This is new. Like what are the different characteristics of wastewater? So first there will be physical characteristic, that how it is looking. So it will be, your wastewater will be very turbid, it will be very black in color, there will be some foul smell coming, there will be huge amount of solid, and temperature might be depending upon what kind of wastewater is there. Organic wastewater is there, then temperature will be normal temperature, maybe due to this temperature is variable thing. Okay, then we have chemical characteristics. Dissolve oxygen, do is dissolve oxygen. Remember, we know that our our water, normal water, has some kind of normal dissolve oxygen. There will be some normal dissolve oxygen that will be around 4 and 5. Okay, now, so once, now imagine that once you have added organic carbon, yeah, some metals, yeah, something you have added in your water. So what will happen, that this the organic matter, what will happen, that it will start consuming oxygen present in your wastewater, in your water. So once, if you see, so that's why, like, it will start consuming DO oxygen, and your DO level will be very low in your wastewater. So means like this DO is indicator of how much your water is polluted. Less DO means your water is polluted, there is something in your water that is consuming oxygen. If nothing is present, then your water will have some good amount of DO, around 3, 4, 5. Okay, now, then something biological oxygen demand, that is different thing I want to be discussing here. Then something chemical oxygen demand. Suppose now you know that some chemical is being added, and to oxidize that chemical, how much oxygen is needed, that is something called oxygen demand. Then we have organic carbon total, nitrogen, phosphorus is there. Phosphorus will be coming from either in our food also, there is some nitrogen and phosphorus also. So it will be coming from there, also from agricultural also. See, this is not characteristics of industrial wastewater. This is a characteristics of common industrial, sorry, common wastewater. Then we have biological characteristic. There will be some bacteria, algae, fungi, protozoa, depending upon the type of wastewater. Okay, so this thing I have. If you want, see, I will be going in very fast manner. I am not here to discuss. This thing has been already been discussed in your lecture. So if you think that something needed to be discussed more, you can just stop me. You can just ask me. Okay. Then I have already said about the color. It will be gray to dark color. Then order, it will some hydrogen sulfide, some like rotating gasman and all these things. Then see this thing, order compound associated with untreated wastewater. So uh, if suppose if your wastewater contain amines, that is this kind of element, then it will have feces smell. And these are some of the common question which is asked in which will be asked in your assignment and all this thing. Like suppose general question is how H2S smell, then that is rotten eggs. Okay, na. So one should have aware of this thing, like uh, one should have an idea of this table, like due to presence of which mineral, which kind of odor is generally industrial wastewater. Then I said about temperature, it depend upon the type of wastewater. Industrial wastewater may increase the temperature of neighboring downstream water. Less DO in wet water, less less DO in warm water, then colder water. This thing is very common. Like if you, like if you boil your water, what will happen, that the temperature, the oxygen which is there in water, it will evaporate. That's why it is saying that this is a common statement. Less DO is available for natural biodegradation organic matter. Okay. Bacteria action increase in high temperature resulting in accelerated. So this is like role of temperature. Now what will happen that um, what will happen that due to less due to now imagine that this is role of temperature, not like what will be the temperature, what is the role of temperature in wastewater. It's saying this thing. Okay, now don't get confused. Till now we were saying that presence of this will cause this, but here it is saying that what is the role of temperature. So now suppose in winter season, in summer season, there is a wastewater has been generated, so temperature will be high. So temperature will be high. So what will happen that this oxygen will be oxygen, there will be less oxygen. Already there is less oxygen, and due to rise in temperature more oxygen will be escaping from your wastewater. And what will happen that at the same time we know that bacteria require oxygen. Then it is if bacteria is acting in the presence of oxygen, or bacteria can also act, there is something called aerobic and anaerobic condition that will be discussed in this detail in upcoming slides, in upcoming lecture also. But just remember that bacteria can act in presence of oxygen also, and in absence of oxygen also. Till time when bacteria is acting in the presence of oxygen, things will be normal. But once the bacteria start to start to work in absence of oxygen, then something called anaerobic condition arrive, and we have, that's why we will be seeing some kind of a smell and all these things. Okay now. So less oxygen, more temperature, less oxygen, bacteria action increases less uh, uh, in absence of less oxygen and high temperature. So your wastewater will be more pungent and more smelly and all these things. Effect of temperature, rate of reaction increases, rate of resolution increases, viscosity of the water also increases. Okay. Total solid, which we have already seen that there will be set a level solid, colloidal solid, dissolved solid, and floating solids. Okay. So the one should have idea of this thing also. See what suppose if you are seeing something, and if you are performing some experiment, then if you are finding some kind of solids, then what will be its normal size. So this chart is very famous chart, everyone uses this. You can see that anything below 0.001 micrometer, that is 10 to the power minus 6 meter, will be dissolved. Okay na. Boundary point, I think there is boundary point of 0.22 micron. Okay na, 0.22 micron. Just go and check. There is boundary point of 0.22 micron. If something is below 0.22 micron, it is considered as dissolved. Then something is between 0.22 to 0.45, then it is known as colloidal. Okay na. It is written in very general way, but there is particular boundary also, that below this thing will be dissolved, below above that will be colloidal, then above that will be settle level solid. But in our in our wastewater we have suspended solid, that you can see. Then something dissolved, we know that sodium is there, calcium is there, that will be in dissolved form, that will be also considered as a kind of a solid also. Then we have organic carbon, which will be volatile in nature. Then something will be colloidal, like milk, which is milk particle is there, then that will be colloidal particles and all these things. There are different tastes, like if you want to find out the what is a total solid, then you have to heat your water. Like there is some I'm how to write here, I don't know. So if you what happened that generally for finding total solid, we take our wastewater and we heat it at 105 degrees Celsius for 24 hour, and then we have total solid. Then for volatile solid, we heat at around 500 degrees Celsius, and for this we use a special cubicle. I don't know. There is a space. See, this at heating at 105 can be done at normal glass, in normal glass, normal, not in our homemade glass, the chemical glassware, crucible, yeah. But for heating at this higher degree Celsius, at this high temperature, there is something called crucible. A glass. It is also a equipment which is used in laboratory that can sustain a temperature around 1000 degrees Celsius. So we put our water in that crucible, and we heat it at 5 degree Celsius. We heat it for only 1 hour, 1 hour, not more than 1 hour. If you are heating at this much temperature, then 1 hour is sufficient. Okay. Then total solid. If you have find total volatile solid, then you can just subtract it, then you will be finding how much total fixed solid is there. Then there is something called suspended solid. So now, how suspended solid is find? We filter, we have our water. Then what we will do, that we know that suspended solid, what is the boundary point? There will be something dissolved, and there will be something suspended. Okay na? So what will happen, that we will, with the help of a filter paper of size 0.22 micron, 0.22 micron, okay na, we will filter our sample. And the water which is at the bottom of our, that is known as filtrate. Bottom in our beaker, we will have filtrate, that will contain suspended solid on, sorry, that will contain dissolved solid. And the water which is all, are we recollecting the big one content? Yes, I said you this, like, till say I will just trying to recap. I will just try to, then I will go to the question answer. Okay now. So this was all about physical parameter. Then we have chemical parameter like pH. Our normal pH is 7. Anything due to presence, either pH might be increasing or decreasing. One should know that the pH formula, pH is minus log H plus concentration. You have to somehow find the hydrogen concentration. Then you have to take log, and then minus of log, that will be your pH. Okay. pH measurement, this thing, inorganic salt, we have acid or alkali, organic matter or toxic chemicals will may be present, microorganism will be present. Then we have biological oxygen demand. I'm not going to discuss it here, because see, like, to in a simple way, like, to degrade organic matter present in our wastewater, there is need of some oxygen. What is that oxygen? That is known as biological oxygen demand. Okay na? Sorry, biochemical, not biological, biochemical. This is very misconception. People say biological. I don't know why I said, but BOD formula is biochemical oxygen demand. Okay na? So organic matter is there, that is degradable. But whenever we are talking about, see, our organic matter will be in the two form, organic form and the inorganic form. Sorry, or will be organic form, but there will be degradable form and non-degradable form. The amount of oxygen required to degradable component is known as biochemical oxygen demand. Okay, the amount of oxygen required by microorganism for decomposition of the biodegradable organic matter, okay na, under aerobic condition is known as biochemical oxygen demand. Okay na. Here you can see that this thing, this thing is like, if you have gone through the lecture, this has been discussed. This is just recapping. Then again we have COD, that is oxygen required for complete oxidation of both biodegradable and non-biodegradable matter. Okay. Then we have nitrogen compounds. Significance of nitrogen is this thing. Various form of nitrogen. There will be free ammonia, high level of ammonia, and all these things. This is nitrification cycle. Phosphate, again, it will be in different form. There are total three form of phosphate, that is H2PO4. Depending upon the pH, which kind of different type of phosphate will be existing in your system. But our normal temperature is around, normal pH is around 7. So most of them exist in the form of H2PO4 minus only. Okay na. Then heavy metals, that is due to what do we call industrial waste removal. Heavy wastewater is through precipitation. We will be adding some chemicals. Then what will happen, that that chemical will be reacting with the existing heavy metal, and we will have precipitation of heavy metals. Then ion exchange, then adsorption process. Okay, you can see what are the different problem due to presence of different heavy metals. You can see chromium, it is not written but it is carcinogenic also, somewhere it is written carcinogenic, means it is cancer causing also. Similarly, you can see the presence of any kind of and see there is a limit, like it's not like a small, you can look at the limit in IS 1050. Suppose if your drinking water has some permissible limit, it is above permissible limit, then that water is also not for suitable for drinking purpose. Okay na, that also need treatment. There is limit for everything. Chromium is chromium, arsenic, cadmium, lead, copper and mercury. Okay, biological characteristic, this we have seen that there will be some kind of bacteria, viruses, protozoa, and presence of anything will cause some kind of disease. Okay, so this is important thing, like what will be the different part what are the different origin of different industry, and what kind of waste that is producing. Okay now so you can, I think you have already gone through this thing. I will just go into the hmm. So see, this thing I was discussing, this thing I was saying, this prevention, control, pollution. So see, if you like I said, if either I can reuse it or either I can discharge it. So you can see that this thing is very, like this table is very old, but latest issue has also come. Like you can see, I think you should for if you are preparing for an exam, I think you should be updated, you should get updated with the latest norms which is there. Okay na. So suspended solid, if your treatment level is such that if you are making your suspended solid within 100 milligram per liter, and pH between 5.5, then you can discharge in marine coast area. Similarly, different what do we call, different, while water parameter has different limits, and as per that you can just discharge there. Okay na. So management is that volume reduction. Again, this thing, like somehow we, if we have to control. There are several how volume reduction can be done. There are several method, like at house also you can, like, I'm not going to strength reduction, volume reduction. If we talked about if we talk about this management of industrial wastewater, then you can see that strength reduction, like it's like a strength reduction, we are talking about particular contaminant. Suppose there is particular contaminant and that is very high, if we somehow reduce their strength, then automatically we will be treating our wastewater in a far better way. Okay, there are several methods. uh, Then something we have equalization tank. Equalization tank is required to equalize the flow and the concentration of incoming wastewater to treatment plant. So see here it was like till this point we were talking about, we were not going into the treatment plant. It was like at our what public can do and all these things. But when it is suppose your wastewater has reached the treatment plant, then there's something called equalization tank. Okay na. So what happened that for treatment purpose we have different unit, and particular unit has particular capacity. Suppose there is aeration tank, then there is primary sedimentation tank. So that has a particular capacity. and that unit cannot take water below a particular limit. So the flow or the amount of water which is reaching at that unit should be maintained. So for to maintaining the amount of flow and amount of the volume the unit might be receiving is controlled by equalization tank. The equalization tank is often required to equalize the flow and the concentration of incoming wastewater to the treatment plant. It helps in providing better mixing, air injected in the basin, chemical oxidation of reduced compounds, some degree of biological oxidation, agitation to prevent suspended solid from settling. Okay, now. So once the flow is maintained, all these things, then water can be circulated. Water can be passed to the next treatment unit in a better way, so that there is no burden on the next unit. So you can see this. These are some of the different equipment used for mixing and all this thing. Mechanical agitation is there. Agitation is done so that now suppose see the use of this particular instrument sometimes depend upon the type of the wastewater that is present type of the uh, type of the wastewater or type of the mineral heavy metals present in your wastewater. I will just give a simple example. For example, suppose that your wastewater contain high amount of iron. So what happened that to treat iron there is no need of a special adding any chemical or anything. So what happened that they will pass the water in such kind of confinement, and they will do agitation. So what will happen that oxygen will pass in the wastewater and iron will react with oxygen and it can precipitate out. So this is the best most common practice used in many industrial wastewater treatment plant. Okay, so that's why the use of this mechanical aggregator is there. It is a bullet type aggregator specifically negotiated along the center line of the length of the tank, operate at this speed and are usually adequate. Okay, now. So you can see that the main thing is that in aeration tank whatever with the help of oxygen, if we can take it out, then we can take it out. Okay, now concept and design, this depend upon the uh, loading and all this thing. Loading means how much mass is coming per unit time and all this thing. There's some formula peak to peak mass loading. See all these thing factors helps in design of different unit treatment unit plant. Okay, now this is like overflow of the treatment plant. Okay, now water will be coming, then there will be some screening. So in a screening, what will happen that larger particles like boulders or stones will be removed. Then we have something called grit means small chunks of stones, plastic and all this thing. So there is a grit chamber, so water will stay for some times, and that is known as resistance time. And the whatever the grit will be there, it will be suspended. Okay, then suspended and that will be taken out. So and then there is something equalization tank that will help to maintain the flow and all this thing. Then water will be passed through primary settling tank. So primary settling tanks, here what will happen that we use the concept of settling velocity. There will be some design parameter, and there will be tank. So whatever the suspended particle is there, it will be getting removed here. Then after that we have biological process or biological process like in between we have more things like coagulation tank, and it's not shown here. So what will happen that there will be some particle which will remain suspending. Here we are removing certain level solid, but there will be some suspended particle that cannot be removed. So to remove the suspended particle we add some kind of coagulants or flocculants. Then we need to have suspend coagulation tank and flocculant tank. Then to remove the biological things, we have biological process. Then after biological process it goes to secondary settling, that biological things will be removed. And finally we have filtration and all this thing. And finally we for UV for like for pathogen to killing bacteria or killing pathogens. We add some kind of chlorine so that our water can be reused. Water is fit for particular use in future purpose also, or water is not get contaminated with some kind of pathogens in future once treatment has happened. That's why chlorine is also added. uh, this is simple thing. There is some example also to analyze the mass loading and equalization tank, what they are trying to find. Hmm. This is some kind of example that in our industry how this BOD COD is increasing. Okay, na. Hmm. So for design of then we have design of, there is something called analytical design and graphical design. Okay, now. So I think I want to be discussing this thing. And analytical design is like just saying. Analytical design is like actual calculation and all these things. Graphical design is on on graph. Okay, now. Then we have something called you can see for neutralizing, like if the see depending upon the type of chemical, the pH of the our industrial wastewater can be, this I will be just read out. Okay, neutralization is one important process to make the water near neutralized range. Neutralized range, that pH should be within 7 to 7.5. Okay, now. See, and neutralization, we have seen that for to discharge purpose the pH should be within some particular limit between 5.5 to 9. Okay, now. So with the help of some chemicals, generally neutralization is done. Suppose if the pH is high, then we have to add some acid, so that not acid like acid type material, so that the pH can be brought in the range of 6.5.5 to 6.5 or 7. Similarly, if the pH is low, then we have to add some basic material and all this thing. And here you can see that lime acid treatment, then we have lime slurry, limestone, then we have sulfuric acid, carbon dioxide treatment, wastewater treatment. And we will see that by adding different thing, if we are adding this, then we have limestone that is CaCO3 in presence of acid, then it will do something to pH. Okay, now. There are uh, different thing. These are some of the question which has been given to you to solve this KSP. Do anyone have any kind of doubt in these questions? See, I'm not going to this is just recap because it's already 7. So I will start problem solving. Means I will start this session. Anyone have any doubt in this question? Anyone? I think there is no doubt. Yes, sir. Okay, so how can I help you, Miss? Like, you can speak if you want. So see, there is the solution. There is the solution of Zn hydroxide containing this much of gene, and solubility product is this much. Okay, now at what pH Gn will precipitate out the solution if the concentration of Zn is this much. What at what pH Zn precipitate out of the solution. Okay, now. So see here we can see that first you should know that whenever something is someone is asking about the pH, you have to first thing is that you have to find H plus concentration. How the value of 8.94 comes in step 3. Here like this thing is okay, just use the calculator 8.18 into 8, 10 ki power minus 18 divided by 10 ki power 3, then take a square root. Just let me check the calculation by my own. Currently, just wait a minute. Just 1 minute. I'm taking. I'm bringing my calculator. Actually, I'm not able to find my calculator, so I think I will use this calculator. I don't know where. So I think we have. See, it will be 8. See here, it is not minus 2. Just remember, it is like a square. It is OH minus a square. Okay, na. So here you have to like take a square root of 8 into 10 ki power minus 15. Okay, na. So I have to take the square root of 8 into 10 ki power minus. Oh, sorry. I have to use bracket 8 into. Sorry, I'm not able to use this calculator. I don't know how this is working. You can see. You can see it 8.9 into 10 to the power minus 8. Just it, you have to take the square root. Once we have the square root, we know the OH minus concentration, and we know that H plus into OH minus is 10 to the power minus 14. Then we have found then we have found H plus, and we know we can find that the pH is equal to minus log concentration of H plus, then 6.95. Okay, now the second question is, at what pH Zn 2 plus will precipitate out. If Zn 2 plus will precipitate out, then the if the concentration of Zn if the concentration of Zn now it is 10 ki power minus 5, again we will be putting these things again, you can find the pH. Same process here. Here Zn 2 plus was 10 ki power minus 3. Here Zn 2 plus will be 10 ki power minus 5. Okay, now I think there is one printing mistake. It will be OH minus. There should be not. It should not be minus 2. Okay, now I will note it down. I hope this is good. Then again we have second question. If the paper mill having itna BOD needs to be proportional in such a way that overall BOD comes to be 500 milligram per liter. The proportion has to be done by mixing domestic wastewater having itna. Find the amount of domestic wastewater flow needed to be diverted if the paper mill flow is 6.5 mld. Okay, now so see how, I don't know. So how things work, like there is something called you have to find there is a paper mill which is coming had the this much flow is coming and contain this much of BOD. Okay, na, like it's BOD just showing that this much of oxygen requirement is there. Okay, na, it's just indication of pollution. Okay, instead of BOD someone can use other thing also. Then we have to find the Q2. Okay, so you see here, uh, uh, here what they are saying that, and the ratio has to be huh. So you have to understand how this question is framed. A paper mill industry is needed to be proportional in such a way that its overall BOD comes to be 500 milligram per. So like see, they suppose there is a paper mill industry. Okay, na, and i- there is a domestic wastewater. Okay, so what happened, and what happened that it is going to the treatment plant. Okay, so what happened that it is this industry is producing 940 milligram per liter of 940 milligram per liter of BOD, and similarly the BOD of domestic wastewater is 160. Okay, na, 160 milligram per liter. Okay, the final BOD which will be coming from here should be 500 milligram per liter. Okay, na, like whatever coming from this side, but the treatment plant which is receiving this wastewater should have a BOD of only 500 milligram per liter. Okay, na, so you can see there is what will happen that the flow will be here will be summation of flow from here, summation of flow from here. So total q, that is total q, you have to find q2. What will be the q2? Okay, so you can we can say that here, suppose here the concentration is 500 milligram per liter, and we can say C. Okay, the final concentration, the 500 milligram per liter is equal to C, and the flow here will be Q1 plus Q1 plus Q2. Okay, Q1 plus Q2, And here what will happen that here there, it will be q1. Suppose this one is q1, this one is q2. Okay, this one is q2, q1, q2, and it will be it will have c1, it will be c2. Okay, so you can just write the mass balance, that whatever the q1 into c1, q1 into c1, whatever the loading is coming from this side, whatever the loading coming from this side, that is q1 plus q2, q1 into c1 plus q2 into c2 will be equal to the c, that is 500 into q1 plus q2. Are you getting this mass balance equation? See, I'm not able to draw properly, but the mass here they have directly written the mass balance equation, but you should know how this mass balance is coming. q1 plus c1 from here, q1 plus q2 into c2 from here, and then finally we are combining it q1 plus q2 into c. Okay, now they have given the value of q1, they have given the value of they have given the value of c1, they have given the value of c2. Okay, they have given the value of c also. You can just substitute the value and you will be fine. There is no need of doing this thing. Okay, now I don't know why they have done this thing, but there is no need of this step. Okay, now just you can put the value here. q1 you know 6.5 mld, c1 you know uh, c1 you know c1 you know 940, q2 you have to find, c2 is 160 milligram per liter, q1 plus you can q1 is already given, q2 is you have to find, and c is 500 milligram per liter. You can substitute the value and you will get the answer, that is 7.99 mld. I don't any doubt. Where is the chat section? Again same thing. There are two wastewater W1 generated from chemical waste. W1 Q1 1 mld, pH this much, BOD this thing, W2 this thing, pH this thing, and BOD is this thing. What is the pH after mixing? What is the amount of NH required to mix the pH to equalize to 7.5? What is the proportional of two BOD need to be mixed to get a equalized BOD of 800 milligram per liter? And also, so you have first you have to find, so every everywhere see here also for this question, first question and third question, same mass balance you have to use. Okay, now mass balance what, like there is two in the, there will be c1 and q1 for this thing, c2 and q2 for this thing, and finally we have a bigger discharge limit, that is q and c. Okay, now q will be c1 plus q1 plus q2, and c you have to find, c you have to find. So for here the c is here, in the case of here this question, c is my pH. So you can see that we know that pH is this thing, pH is minus log H plus concentration. So again you see they have utilized the same formula, this formula only, q1 into c1 plus q2 into c2 divided by q1 plus q2. This q1 into pH plus q2 into pH divided by q1 plus q2, finally this thing, and they have taken the log, and finally they have find the pH. Okay, now the second question was the, if the pH is this much, how much I have to add so that final pH is 7.5. So required pH is 7.5, that is 7 10 to the power minus 7.5. So and we know that our pH if this is the pH, then OH concentration will be this much. We can find into by H plus into OH minus by doing this mathematical expression. Our pH, our system of pH, our wastewater pH has 4.04, and we have to make it 7.5. So there is a difference of this much. Okay, now so the how much OH should be added, this much minus this much, that will be final amount of NOH that should be added. Okay, now so this much OH, it is in mole per liter. Okay, now but you have to report your answer in liter per day. in question it's written it's written that you have to report your answer, no, not written, but generally what will happen that if there is a treatment plant, then the amount of any chemical will be always added it in liter per day, that this much liter of that chemical is required on that particular day. So you know the OH minus concentration, you know the molecular weight of OH. So this mole can be converted, uh, uh, I think, okay. Similarly, this thing can be done like by multiplying with molecular weight. You can find the required amount of OH that should be added in your wastewater. Similarly, last question is also same thing. You have to find Q1 by Q2. Okay, then same mass balance formula you have to apply. Okay, so these are the question of see the assignment question is directly from your what do we call the lectures. So miss, I will request you to participate in the question answer. I have solution of each and everything, a detailed solution, but just take a few minutes, try to answer it. You will see that whatever I have discussed or whatever has been discussed in the lecture, the question are directly from those lectures video only. So the first question is, which of the following statement is and are true for equalization tank? This is a multiple correct question. Okay, na? This help in dampening the shock load. This help in equalization of the flow only. This provide this is provided after the biological treatment. Okay, so if and there is none of these. Okay, so if you have gone through the pictures, you can see that the equalization tank is provided at the start of the treatment plant. Okay, now so the first option is incorrect. Sorry, third option is incorrect. Third option is incorrect. Someone is saying A. Okay, first one. Anyone more? This is multiple correct. Is and R. Is second option correct, or both are correct? A and B. Take your time and go. Just try to remember. Actually, both are correct. Shock loads. Remember shock load for which thing? Shock loads for the upcoming unit. So it will equalize. Equalization tank have the purpose to equalize the flow. Every unit like the first unit is primary sedimentation tank, and primary sedimentation tank are designed based on the discharge value. There are many factors, but one of the factor is discharge value. So the water going in the primary sedimentation tank should have a constant discharge, and that discharge or flow are same thing. So that the flow should be maintained. That's why this equalization tank is used. So it help in dampening the shock wave. Yes, first one is correct. This help in equalization in flow only. Yes, it only help in equalization. It has no treatment. It does not help in any kind of treatment. It just help in equalization. Just go through the lecture. You will understand it. It is provided after the biological treatment. No, biological treatment is always done at the end of the treatment, like not end, like it is after primary sedimentation tank, then we have coagulation tank, flocculation tank after that. So one, the correct answer are A and B. Okay. See, there is one thing partially correct I have written here, because apart from if you have gone through the lecture, you will see that this equalization tank have something called aeration unit and all this thing. So but if it is partially correct, but you have to mark. If you want to get full marks, you have to mark both things, A and B. I have given the reason also. The equalization tag is designed to buffer the variation in wastewater characteristics as sudden fluctuation in flow rate, pH, and pollutant concentration. Okay, so uh, what will happen that our wastewater is coming from many area. Okay, now from many household, from many industry, and different industry will have different pH, different flow rate. So it's not like that for treating particular industry we have to, like, our treatment plant has been designed for a particular range of value. So we want our wastewater to be in that particular range only. We cannot treat if a water is coming with very high pH, and if a water is coming with low pH, that should not be the case. The case, that's why it is kept in equalization tank, so that everything which is coming there will have a uniform pH or uniform pollutant concentration or uniform flow rate. Okay, it ensure the downstream treatment processes. See, first part was that pH and all things should be constant for our my wastewater, and second thing is that the upcoming unit which is coming after the equalization tank have particular design, like parameter, that it should not, the water coming, it has some certain capacity, it should go below that capacity. That's why it is preventing the system overload or inefficiency. Second thing I have already discussed. Same thing. uh, no, it is correct but partially correct, but even though it is partially correct, you have to consider it as for your answer. Hmm. This is incorrect. If you have gone to the picture, you can see the biological treatment come after primary sedimentation time. Second question. Try to. I want everyone to participate. Which of the following is and are false? Again, it is multiple correct. See, whenever there is and are, you have to, like, you have to think twice. Someone was marking only A and B. It's not always true that. Just think twice. Whether single correct or whenever there is a multiple correct question, go through each and every option and then try to answer it. Anyone? ABC. Reduce. It is saying false. First one is the true. How can you say this is false? First, see, read the question. It is asking which is false. Reduce, reuse, recover, recycle are the three R of industrial wastewater. It is too true. Let's see the answer. Correct answer is D. Recovery of previous metal does not help in strength reduction. I think you have read the question wrong. ABC are correct, but you will lose marks if you do this thing. So, recovery of the previous metal, D the correct answer. So this is very common. 3R, 4R, 5R. These are very general trends. Reduce, like minimize the waste generation at the source. Recover, means extracting valuable material from the wastewater, and then recycle, treating, and reusing the wastewater in the process. So this is our 3R. Then volume reduction can also achieve by changing the modifying the process and equipment. True, by improving the process efficiency or upgrading equipment, industry can reduce wastewater generation. Example: switching from water waste to dry cleaning process in certain industry reduced wastewater discharge. Okay, volume reduction is like this is also true. Third question was proportioning of wastewater streams in exercise to turn the mixed wastewater and available for next treatment process. Or equalization, this is also true. Like if uh, this is also true, like mixing equalization balance the characteristics of the mixed wastewater seems to stream to ensure stable treatment efficiency. Again, it is related to equalization tank only. It prevents excessive variation in pH, organic load, or toxic substance, allowing the downstream treatment for function. Okay, I think the third option was, which was false. Recovering of the precious metal does not help in reduction. uh, Recovering precious metals such as gold, silver, copper, nickel from industry wastewater actually reduce its overall pollutant strength. So, see, not about precious metals. If we are removing any kind of pollutant, like any kind of metal which is uh, any kind of like contaminant is there, if before treatment somehow if we are trying to remove it, then obviously it will like it will cause a burden to our different unit in treatment plant. Okay na. So many metal laden waste stream have high oxygen demand and toxicity. Removing metal can help lower contaminant level, making further treatment easier. If you remove the if you remove something from your wastewater before treatment somehow, then obviously the your overall treatment process will be easier. So it should be does help. It should not does not help. That's why it is false. Again, question to solid. Again, read the question again. Is and are false. B, just read the question and then take your time and then answer. This type of question, I think you might have received in your assignment also. Last date is 5th of February. I don't know. 5th of February is the last day. C, actually the C option is this thing. Okay, na they miss. They I forget to enter, but A, B, and C option is here. Anyone with any answer? B is the B A. B is the only B is the false. Okay, na all are correct. So this is very common. Total solid will be total suspended solid plus total dissolved solid. Okay, na. Again, suspended solid do not pass through. Again, I have said you how this. I was saying you this thing, like how the suspended and dissolved solid is. First we have this. Nor suppose I will be taking a normal beaker. I will be adding some 100 ml water, and if I keep it at 105 degrees Celsius for 24 degree, we will be getting total solid. Now suppose with the help of filter paper, suppose this is our filter paper. This is our filter paper. We we keep beaker here, and there is filter assembly, like we have to apply pressure, create vacuum and all this thing. Then what will happen, that all the filtrate will be here. All the filtrate will be here, and the this filtrate will contain dissolved solid. Okay, na total dissolved solid. And the suspended solid will be here at the top of the filter paper. This filter paper is heated at 105 degrees Celsius, and for total dissolved solid, be heat at 180 degrees Celsius. Okay, now for 24 hours. So either we can find the total solid by this process or by this process, but generally finding suspended solid and dissolved solid is preferred, because by performing two experiments you can find total three things. Okay, by performing this single experiment we will be just finding total solid. If you have to heat at something at 105 degrees celsius and 108 for 24 hours, then why not to do both the things? Okay. B option, which was incorrect. The residue that remains after TDS are ignited at itna as term as total volatile solid. No, total volatile solid. The TDS are not kept at TDS is kept at 180 degrees Celsius, and that is TDS. Okay, now the remain the at 500 degrees Celsius, the sample which is kept is our pure sample which is kept just to know what is the total amount of volatile solid present in there. Okay, this was a proper table has been given has been provided to you in your lecture notes. So if you have any kind of confusion like how volatile solid are found, how fixed solid is found, how, just remember the different temperature. For total solid 105 degrees Celsius, for total suspended solid, for total suspended solid you will be heating at again 105 degrees Celsius. For TDS, that is total dissolved solid, you have to heat at 180 degrees Celsius, and for volatile solid you have to heat at 500 degrees Celsius. Okay, now, so what will happen that initially you have performed total solid experiment, so from there you know the total solid. If you heat it, then you what will happen that all the volatile solid will get evaporated, and in your beaker only fixed solid will be there. So you can take the way of your fixed solid and you know the total solid, then you can subtract the total solid minus fixed solid and you will be getting volatile solid. This is clear by bifurcation, no confusion. Just remember the what do we call temperature, at what temperature, for which purpose we are heating at which temperature. Okay. Volatile solid refers to the portion of solid both dissolved and suspended. Volatile solid can be anything, maybe it can be dissolved also, it can be suspended also, burn of high temperature. Okay, correct statement. The statement should be the ratio that remains after TSS, not TDS, are ignited called fixed solid and burned off portion is volatile solid. I hope this is clear. Again, this is why these thing are other option are correct. I have also discussed, but I think you have all have idea. Imhoff cone, remember Imhoff cone look like this thing. Okay, na. So what will happen that we took our wastewater, we add it, we left it for 1 hour. So what will happen that all the settlable solid will get deposited here in this cone, and there is marking here. Okay, so it will be 5 mm, 6 mm, 7 mm. Depending upon that we will be reporting our that in our 1 liter of solid this much of suspended settlable solid are there. Okay, now settlable solid are fraction of suspended solid that settle at the bottom of graduated in of graduated means there will be marking here within a specific time, usually 1 hour. The test is commonly used in wastewater treatment to assess the sedimentation characteristic. Final correct answer is B. Fourth question, I think everyone should answer this question. H2S is generated in presence of H2S. Which kind of a smell? B smell. C rotten egg. Huh. This thing is correct. So see this due to H2S, which is colorless toxic gas, has rotten egg smell. Okay, na. So this thing, this C is correct. You should also know, like I have this thing is in your table also. Like there is one table now that presence of which mineral gives such for like due to presence of amines we have feces smell. Okay, na. See here amines, due to presence of amines we have feces smell. Similarly, due to presence of mercaptan we have cabbage smell, some decayed cabbage smell. Like, you should know everything. That's what I want to say. Decay phase is due to presence of some these kind of these kind of minerals. uh, you can always check that table. In You will see, I am just listing out these three kind of a smell, but that table contains more. Okay, what is the purpose of determining BOD versus COD ratio? This is single correct question. Again, see, this thing I have not discussed, so it is expected that you must have seen your video lecture. If you have gone through the video lectures, you might be able to answer this question. I have not discussed this thing. I have just said you this thing. BOD is used for degradable organic matter, and COD is used for both degradable and non degradable organic matter. I think if you are like based on these information also you can answer this question. What is the purpose of determining this thing? To check the oxygen level in wastewater. No. To check the oxygen level we will checking dissolved oxygen. I have said this thing. S. S या A. The correct answer is that biodegradability. See, A is the correct answer. So see, no, just based on this information there was no like. For more detail you can always like go to your video lecture, but based on this information that BOD tells about degradable organic matter and COD tells about uh, this thing, both organic plus degradable plus what do we call non-degradable. Okay na. So this ratio is important parameter used in wastewater treatment to assess how easily organic matter in wastewater can be biologically degraded. Okay, this is see a higher ratio. Suppose your ratio is 0.5 greater than 0.5 indicate that wastewater contain mostly biodegradable organic, meaning it can be treated effectively using biological process. But if your ratio is low, like in industrial pollution, because in the industry we have mostly or inorganic non biodegradable organic matter. Okay na. Suggest a presence of toxic or non biodegradable substance requiring chemical or advanced treatment method. Other option are incorrect. For to no, DO is check to check the oxygen level. Okay, acid neutralizing capacity, that is another thing that depend upon the pH how like for that acid neutralizing capacity, for that we something go on the parameter called alkalinity. We do not rely on this BOD. Which of the following pollutant is generally not found in industrial wastewater? Not found. Again, read your question. Read the question. Not found. See, all. I think you should all participate. I don't know why only single person is answering the question. What about other? There are total. I don't know. Just there are total 12 people. I encourage everyone to please participate. Else it will be like single way communication. I will be just keep speaking. See, you are saying which is not generally found in industrial wastewater. B, someone say B, someone say C. See, sediment. If you like, in this type of question, it might seem very easy, but like you have to think, like where heavy metal is found in industrial waste. That is correct. Industrial waste. See, if you see dairy industrial wastewater, then that contains some amount of milk and all this thing. So that will have very high BOD. So BOD is also fine. So C won't be answer. A won't be also my answer. Color is always there. Example I have said about chromium, due to chromium our water is greenish in color. So this will be also not my answer. So the answer will be B, sediment. In industrial wastewater we don't see sediments. Where sediments? Sediments are generally found in a storm water or agricultural wastewater. Okay na? In an industry where from where does sediment come? The correct answer is generally not found in industrial water, insignificant. Heavy metals generally found like lead, mercury, chromium, arsenic, heavy metal. Sediment generally not primary pollutant in industrial water. Sediment are more common in storm water, construction site, agricultural runoff rather in industrial wastewater. However, some industry like textile, mining, paper may release, but this is not always true. This thing I was telling about dairy industry. Addition due to lime, odor, any other reagent. Addition due to but if you add lime, then it won't produce sediment. It will just dissolve. It will dissolve. See, lime. See, you are talking sludge will come. Sludge will no. Sludge won't come. Does fiber come as sediment in wastewater? No, sediments are inorganic particles. Sediments, organic particle are generally sorry. Inorganic particles are sediments. Fiber, I don't know which kind of fiber you are talking. Fiber in textile industry, huh? That will be considered as sediment. See, but this is not universal, na. Like you are if we start to see particular thing, if you try to answer this question, then in textile industry you might in textile industrial waste you might not find heavy metal. So but when we talk about industrial, majority of the industrial wastewater contain heavy metal, but not majority of the industrial wastewater does not contain sediments. This is universal truth. Like sometimes you have to huh, your point is true, but you have to see other thing also, other parameter also. Someone say see if someone is like if someone is talking about there are many industrial wastewater that there you will find some industrial wastewater that does not have some color, but it doesn't mean that industrial wastewater it will be universally truth. See, that's why here I have written generally not found in industrial waste in significant amount. Here also I have written are more common in storm water. However, some industry like textile, mining, and paper construction, this thing I have mentioned to avoid any kind of confusion. Think about this point: textile, mining, the mining industry will also contain huge amount of sediment, but that is this is for just those particular case. I hope this point is clear to you. Coming to the seventh number question, that was this thing I also I have not discussed. This is multiple correct, and for to answer this question, you have to like see your video lecture. So A, it is multiple correct. So If you are sure, see, if multiple correct also, then single option can be also correct, but don't be in a hurry. Okay, I have got one answer. The but correct answer are A and C. Graphical method are more accurate than analytical method for determining the volume of equalization tank. The tangent to the graphical method are drawn perpendicular to the mass of the curve of the outflow. Okay, I might not be able to explain in a better way because I have not also gone through this thing, but I have some few explanation. See, uh, graphical method are more accurate. See, the analytical method is more accurate. See, obviously, whenever in graphical method we are just plotting some diagram, and based on that we are trying to determine. See, if you have gone through the, where did it go, if you have gone through the design thing, you might have seen that this type of plot is drawn and a perpendicular line is drawn, and based on the difference we try to find out the maximum discharge and all this thing, and based on that we trying to find the length. But that is not a good method. It is but in analytical method we perform the calculation on paper pen, and based on that we try to find out the dimensions. So this statement is false. That's why it is our answer. Okay, na. Just remember they were asking false. That's why we were okay. Analytical method involve determining of deficit surplus by cumulative volume and inflow outflow. Okay, this is true. Like you might have seen that we try to find the cumulative value. Suppose for this particular time, x amount of water is coming. Then in the by amount, x plus by amount will be coming. Then the cumulative value will be x plus by, and based on those value, we try to find our equalization tank volume and overall discharge. So if you see for this question, I think all of you should must practice the numerical question which has been discussed in your video lecture. You will see like you will see a discharge value for particular hour will be given. Then you have to find the cumulative value. Then there is some formula that for peak period you have to multiply by zero point 0.8, yeah, something. I don't remember the exact value, but you have to multiply. Then based on that peak value you have to find the volume and all this thing. So this thing is true. That's why it is not our answer. See, in graphical method, tangents are typically drawn parallel to the mass curve, not perpendicular. See, again, same diagram. This we try to our curve look like this, and we try to we plot parallel line, not perpendicular. Perpendicular means this. No, we do not draw this kind of things. That's why it is incorrect. That's why it is our answer. Vertical ordinates is the measure between mass curve of the outflow and tangent. This is also related to the numerical question. So if you have not understood this question, I will suggest you to go and read those lecture or watch those videos. Now we have one numerical question. I want everyone to solve. I will give you 2 minutes. The formula is very common. You have to just find the peak to minimum ratio mass load factor. It is 47, 48. I will wait. What do you want? Should I solve it? Yeah, you will solve. How much time we have? We have more 10 minutes. So this was our question. Like I'm solving it. Okay, now because we have only 10 minutes. Hmm. 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 The peak and the minimum flow of the wastewater reaching to ETP. That is ETP, STP, there is STP, STP, ETP. These are common term used for wastewater treatment plant, effluent treatment plant, and then we have sewage treatment plant, ETP and STP. 1200 liter per day, then 1400 liter per day, liter per day, and its corresponding BOD ratio are this much and this. They are just simply asking to find out the ratio. This was very simple question. The peak mass load will be peak by BOD concentration into peak flow, that is 420 is the peak concentration, and the peak flow is 12,000, sorry, not 1200, 12,000. 12,000. So that will be this will be in milligram per hour, because the unit you can say the milligram, and it is also, see, uh, here there is a unit conversion, okay na, so it is in milligram per liter, okay, milligram per liter, and here it is liter per day. Day has been converted into hour by multiplying by 24. So here there is a in denominator there will be 24 also. Okay na, 24. Okay, 24. Then finally you will be getting this thing. Okay na, 5,000, 50,000. This much 50440 milligram per hour. Then to convert milligram into gram, they have divided it by 10 ki power 6. Okay na, divided by 10 ki power 6. 1 2 3 4 5 6, then it is 5.4 into kg per hour, but there was no need of doing this thing, okay na, because you have to find the ratio. Similarly, oh, actually, one step has been missed here. So similarly, we have find peak BOD now. Similarly, minimum BOD will be also find by multiplying this 1400 into 250. If you multiply these two and divide it by 24, then you will be getting the value 0.35. Then you divide it, then your ratio will be 14.4. Okay. Any doubt in this question? Next question: what is the equalized phenol? Just solve it. Take 1 minute and solve it. This is very easy question. Mass balance question. I have already shown you two questions related to this theory. Use the concept that suppose if something a coming from this area, discharge is coming from this area. Suppose it has a concentration of C1 and Q1, and here it is C2, Q2, and then our final concentration is C1 and Q1. Sorry, C. Sorry, not C. Simple C. Simple C and Q. Then C will be given by C1 into Q1 plus C2 into Q2 divided by Q1 plus Q2. A paper mill generates this much of MLD of wastewater having phenol concentration itna milligram per liter. While it is only 5 milligram per liter generated at the itna liter per capita per day. Per person is generating this much, thousand liter at 5. So remember, you have to convert into MLD first. So you have to multiply by population here, okay na, then you will be converting it in MLD. Here it is 1.2 million liter per day. but here it is 100 liter per capita, means per person per day, and the population is given you 1200. So just see, this is the general formula. C mix will be q1 into c1 into q1 plus c2 into q2 divided by q1 plus q2. Okay. Okay. So c1 it is given you 1200, q2 it is. So now for q2, for finding q2 you have to multiply it by 1200 people. Okay, now because population is 1200, then q2 will be this into 1200, and as you have to convert into million, then you have to convert, you have to this million means 10 ki power 3, 10 ki power 6. Okay na. uh, so it will be, it's wrong written here, it will be 3 more 0. Okay na. 3 more 10 ki power 6, as we are converting into liter, liter is converting into million, so it will be divided by 10 ki power 6. So finally q2 will be 1.2. Any doubt till now? I don't think so. See, then you know q1, c1 you know, q2, c1 you know, q1 you know, c2 you know, q2 you have found 1.2 mld. You will put the value all here, and finally you will get c max is equal to 603 milligram per liter. Last question of the day. This is simple question. Liter having pH 3.5, while another produce 8.5, having generated itna 1.1. Here it is liter per day, here it is kiloliter per day. Okay na. So either you have to convert it into kilo, or either you have to convert it this one into liter. So to convert into kilo you will divide it by 1000, or you can here multiply it by 1000. So multiply here, divide here, multiply. Okay. So first you have to, again formula will be same, c1, this formula will be used. C1 into q1, here c1 will be h plus concentration. In next question it will be h plus concentration. Similarly you have to find the final h plus. H plus is equal to h plus is given, uh, then pH for 3.5 it will be h plus will be 6.3.61. For at pH 8.5 it will be 3.613 into 10 to the power minus 9 mole per day, mole per liter. So total H plus will be, q1 into h, uh, for first stream it will be h plus 1 into q1, they have multiplied it, and again here I have converted 1.1 kilo lkd to liter per day, kilo to liter. So h2 plus h plus coming from the second stream will be this much mole per day. Okay na. So total will be, see I have just written it, but I could have directly put the value here. Okay na. I could have put the value directly here. So total H plus is this thing. Then finally Q mix is equal to Q1 plus Q2. So H plus will be total H plus, that is C1 into C1 into Q1 plus C2 into Q2 divided by Q1 plus Q2. H plus will be this thing 2.63. Then we can finally put the value of pH. We know that pH is equal to minus log H plus concentration, and we have the pH of 4.58. Please repeat the question 9. See, you have to use this formula. I have some, if something is coming from one stream, something is coming from second stream, then we know that both of will mix up, and it will flow with flow of q1 plus q2. Okay na. Something is coming with c1 and q1, something is coming with q2 and c2. The flow, whatever the amount is coming from here, whatever the amount of is coming from here, it will mix up, and it will give you the flow of q1 plus q2. Okay na. So we know that something called mass balance, that whatever is coming from this side will have this, the same amount will be going from this side. So the final expression will be C1 into Q1. Here it is written C1 into Q1 plus C2 into Q2 is equal to C mix, which is going here, C mix into Q1 plus Q2. Okay now. So here it is saying that there is a mill, there is a mill which is producing this much of MLD of wastewater, that is million liter per day wastewater, and have concentration of 1200 milligram per liter. But in our house there is one small town which has population of 12,000 people, that produces 5 milligram per liter of per person, but has a discharge of 100 liter per CD, means capita, means per person per day, means per person it is producing 100 liter. So total population is how much? 12,000. So total production will be 12,000 into 1200. Okay now. Let me explain you again. C1 we knows Q. Have you miss? Do you have clarity about this formula? Do you have any doubt in this formula? How this we get C makes is equal to Q1 plus Q1 into C1 plus Q2 into C2. Any doubt in this thing? Clear? Okay. Then Q1 is milligram per liter, that is okay. Q2 is 1.2 mld, that is okay. C2 is 5 milligram per liter, but Q2 is, we have to convert Q2 into this same unit. Okay now. For this thing, what I am doing, that we know that 1000 liter per capita per day. Okay, okay, per liter per capita per day. Liter per capita, for to remove this per capita या per person, we have multiplied by whatever the pollution, that is 12,000 pollution population. Okay, again it will be here 10 की power 6. Okay na, not 10 की here there is a little bit mistake, writing mistake. It will be 10 की power 6, 10 in 10 की power 6. Okay na, 1 followed by 6, 60. That's anyone. Okay, clear. Okay, so you see that we have found out Q2. Q2 come out to be 1.2 mld. Once we know our Q2, then we have put the value here. C mix is equal to C1, that was 1200 milligram per liter, into Q1, that is 1.2, C2 into Q2 divided by Q1 plus Q2, and finally we have answer of 603 milligram per liter. Any more doubt? It is already 8. Please repeat the analytical versus graphical method. See, in analytical method, I think better way to explain is this thing. Here you can see they have talked about how to design. Okay, now. So in graphical method, what we do now, in we what happened, that we know our flow, we know our what do we call, volume, and whatever the amount of water coming to our wastewater. Okay na, to our treatment plant. Okay na. So what happened, that we plot some diagram, cumulative value diagram, that is known as mass curve flow. Okay. And what happened, that based on the value of this curve, we find A and B, and based on that we try to find out the volume of the equalization tank. Okay. So this is like graphical method. You will be given some value, you know the discharge that is coming from before treatment plant. We first do analysis, and from analysis we came to know that at particular time, that in a day we have 24 hour. For first hour this much water is coming, in second hour this much amount of water is coming. We know this value. Okay now, based on this value we plot some diagram, mass flow curve, and it is miss, I don't know, miss, I am Mihir sir, no sir. Oh, so this is another thing. Okay, then we plot diagram, and based on the based on the, what do we call, based on the tangent, we find out the volume of the tank. You can see here the tangent is coming at the point B. So this point B, and here the tangent is coming cutting at the point A. So we will note down the point, the what do we call, the value of point A, and we will note down the value of point B. And it works on that, like it works on the principle that if maximum amount of water is coming at a particular amount, like there will be a, in a 24-hour day, there will be a point where there will be maximum water will be coming, and at and on same day there will be another point where there will be minimum amount of water is coming. Okay now, so based on those based on those value, they try to find out that I have to design our equalization tank in such a way that it can accumulate the maximum amount of water that is coming in our tank, in, that is coming through in our wastewater treatment plant. Okay, so this method is based on that principle. Okay, we plot diagram and we take out the value. And there is another method, that is not analytical method, that uses some kind of formula, and based on that they try to find out the community, this value and all this thing. So here you can see that graphical method is very old and does not provide accurate estimation of value. Then analytical required drawing and all this thing, but in analytical method you can see that in this is another thing. But I hope this is clear. When miss to know more about this, I will request to go through the lecture. Sir has discussed in a great depth. I am just giving you the overview. Any more doubt? I will request you to please join the next session also. And next session, I think we don't have time, but in next session we can have one-to-one conversation. Like some of you were saying that please go through the assignment problem. So in next session I will just have I don't have time right now, but in next session I will just we will do sort out this thing that we want recap or not. Okay na. Next session will be next Tuesday, that is 4th of next Tuesday is what, 4th of February. Okay na. Then for today I think I will be ending the session. It's already 8 past. So, good night, everyone. Thank you for joining, and I request you please, and from next time be active, like be participate in the question and answer. For that, please go through the lectures. Then only you can answer the questions. Else you won't be able to answer. Okay, I am ending the meeting. Any, I am ending the meeting, everyone. Thank you for joining.